Section 9.3, Graphing Hyperbolas. So, first thing we're going to take a look at is the standard equation of the hyperbola. Notice that it looks very similar to the standard equation of an ellipse, except there are some key major differences. The first that you'll notice is that there is a minus sign between the two fractions. This is a dead giveaway that you are working with a hyperbola and not an ellipse. The second thing that you'll notice is that a horizontal ellipse has the x term in front and the vertical ellipse, the vertical hyperbola has the y term in front. This means that when you're graphing, the horizontal hyperbola will end up looking like this, and the vertical hyperbola will look like that when you're finished. Another key difference is that the a term is always underneath the first fraction. And this lets you know how far away your vertices are from your center. In an ellipse, the a is always the bigger number. That's not true for a hyperbola. For a hyperbola, the a is always first, so it might not necessarily be the biggest number. Another difference is that the equation for the focus has a plus sign in between the a squared and the b squared. So I always remember that for a hyperbola, since a hyperbola has a minus sign, the ellipse equation will have a plus sign, and the focus equation will have a plus sign. For an ellipse usually always has a plus sign right here, and it would have a minus sign right here. The B value is still the distance between the center and the co-vertices, and C is still the distance between the center and the foci. The foci of a hyperbola will exist on the outsides of your parabolas. So the same as when we graph a normal parabola. Your parabola is always eating your focus. Here your hyperbola is always eating your foci. For hyperbolas, we have an equation to help us find the asymptotes that go through a hyperbola. And this will be a little bit easier to understand when we actually start graphing. But basically what the equation is its point slope form, and it is using your center, h comma k, as the point. So as you'll remember from back in Algebra 1, point slope form is y minus y1 equals m times x minus x1. It's the same thing. M is going to be either up b over a for a horizontal parabola or up a over b for a vertical parabola. And the center is the h comma k. That's your point x1, y1. Again, this will be a little bit easier to understand when we actually start graphing the hyperbola. So let's go ahead and do that. So the first hyperbola that we'll graph is y squared over 4 minus x plus 1 squared over 3 equals 1. So we'll go ahead and draw a little line right here to separate it. And I'll start by sketching a graph. Oops. Erase that bad boy. There we go. Sketching a little graph down here. Oh, it keeps doing that. Okay, so the first thing that you'll notice is that the y squared is in front. So we know that this is going to be a vertical hyperbola. And also, we know that the center is going to be at -1, 0. Don't make the mistake of always looking at the first term and then the second term. Always look at your x value first, then your y value. Okay, so let's go ahead and graph our center first. So -1, 0, right there. Okay, then we know that our vertices are going to be up 2 and down 2 from the center, since there's a 4 underneath the y squared. So up 2, down 2. All right, and then underneath our x value, we have a 3, which means that we need to move the square root of 3 side to side. So again, you don't have to be super accurate. Just kind of estimate where the square root of 3 would be. We know it's about 1 point something, 1.7-ish more specifically. So just do the best you can with putting your value 1.7-ish. Okay? So now what we're going to do for the hyperbola is make a box around the points that we just drew. And this box is going to help us draw our asymptotes. So there's the box, and then the asymptotes are going to go through the corners of the box. Like that. All right. Then we want to put our parabolas on. So remember that your parabolas are always going to attach, I missed it a little bit, there we go, to your vertices. And you can use the asymptotes to frame your parabolas. You do not have to find 2 points that are actually on them. All right, let's label a couple of things while we're at it. So we know that our vertices ended up at -1, 2 and -1, 2. Our co-vertices are a little bit more tricky, and since it's a radical, we can represent it this way. We can say, well, we started at -1 and we moved plus or minus √3 to the side, and the y value for both of our vertices are at 0. All right, you are almost done graphing your hyperbola, but we still need to find the foci and label our asymptotes. So let's label our asymptotes first. All right, so we know that our center is at -1, 0. So our k value is 0, so y minus k is just going to be y. All right, and in this case, what we did was we started from the center, and we went, let me change colors on the pen, up 2 and over √3. So we're going to say plus or minus, up 2 and over √3. And you do not have to rationalize the slope, so you're welcome. All right, and then our center is at -1, so that's x plus 1. And you're done. You don't have to do anything else for the asymptotes. That equation is fine. All right, the last thing we need to find are our foci. So to do that, we're going to use the equation c squared equals a squared plus b squared, same as the Pythagorean theorem. So c squared is going to be 4 plus 3, which is 7. So we know that our C value is going to be the square root of 7. Again, you don't have to be super accurate with this, but you want to make sure that your foci are in line with your vertices. So you're going to start at the center and go up the square root of 7 and down the square root of 7. The square root of 7 is a little bit more than 2, less than 3. So about right there is fine, and about right there. Those are your foci. All right, but we still need to label them. So they have the same x value at -1, and we started at 0, and we went up root 7 and down root 7. So -1 comma plus or minus root 7 is good for labeling your foci. All right, let's go ahead and graph the next hyperbola. Actually, why don't you try to graph it on your own, hit pause, and then see how you did, all right? All right, I'm going to start graphing it. Okay, so we have x plus 3 squared over 144 minus y minus 2 squared over 25 equals 1. Okay, so here the x term is first,